In Mario 4, we looked at adding the ability to draw Mario onto the screen, or at least our version of Mario. It's an alien. It's not quite the same. In this case, we're going to implement the ability to move Mario. Now you can see there that he's sort of moving to the right there. Not a whole lot is going to be changed with this. We're just going to really draw a entity, sort of the sprite moving left to right, sort of shifting. But in the next update after this, we'll get into actually animating the entity and also talking about state machines a little bit in more detail. But this one, we're going to really just be doing a simple translation of Mario and also sort of separating the movement of Mario from the camera movement such that the camera will track Mario and we won't be scrolling the camera manually. So why don't we go ahead and go into the player class here. I'm going to set up actually no, what I want to do is in the map class first off, what we want to do is not have all of this code here, which is in charge of just hard scrolling the screen. We want to actually keep track of where the player currently is, really. And so what I'm going to do is just sort of get rid of this, all of that, and we're going to tie the map sort of camera exactly to where the player is moving. And we're going to account for the player being in the middle of the screen by shifting halfway to the left, virtual virtual width divided by 2. Now what we can do is we can say cam x, and this is going to be kind of I would say mouthful really. It's going to be a lot of coding, but we're going to write this and then we're going to look at it in reverse. So you can see I'm using math.max. I'm going to be using a couple of nested math.min calls as well. So say math.max of 0, math.min gets the self.player.x minus the virtual width divided by 2. So again, that's taking into consideration half the screen being to the left of our player. And then after that, I'm going to say we also want that to be compared against the math.min of self.mapWidth in pixels minus virtual width. So this is accounting for when the player gets all the way to the right side of the screen. They should be they should essentially have the whole screen as a buffer to not let the camera scroll any farther than that to the right. And then so we're going to say self.player.x is the end of that. And so like I said, it helps to actually read this in reverse. So we're going to ensure that the camera always takes the lesser of the map width in pixels minus virtual width and where self.player.x is. So if the self.player.x is any further to the right than a full screen width away from the right edge, it's going to take the lesser of those two, which is going to be the map width in pixels minus virtual width, so a screen width. And then it's going to take even lesser of that. It's going to take the math.min of that and self.player.x minus virtual width divided by 2. So that's accounting for half of the screen space to the left of the player. And this is if the player is any further left than a whole screen size away from the right edge of the screen. And then lastly, we have to prevent the player from going any farther left than 0. So we want to always take the max of where the player's x is in relation to that and 0, essentially. Or rather, the players.x minus virtual width divided by 2. So that is essentially it for clamping sort of our map, our camera X, to wherever the player's position is and giving them half a screen of buffer and sometimes also a full screen of buffer. Now another thing that we need to do is go into the player class and actually add some keyboard input to give us some velocity, some movement. So what I can do is say if love.keyboard.isDown, and we'll just use A and D for now, so WASD. If it's A, else if love.keyboard.isDown of D. So if it's A, I want the character to move left, so I'm going to create a variable called move speed. And I'm going to just set this to 80 for now. So we'll say move speed is going to be 80. And then what I want to do is say self.x is equal to self.x minus move speed times delta time. And self.x is equal to self.x plus move speed times delta time. And that should really be it for this example. So I'm going to go ahead and just run this, make sure this works. Fingers crossed. Okay, we are currently over the tiles here, but you can see we're moving. And also, interestingly enough, we're moving, but we're not actually getting, the camera's not moving beyond the edge of the map. So we're clamping, and as soon as we get in the center, it follows us, and then we can go to the edge, and it stops once we get to the edge. So that's a very important aspect of the app, is the fact that we can move in the center, we can have the camera track us, but when we get to the left or the right edge, the camera just stops and stays there. And this is behavior that is reminiscent of how most platformers work, because it's often the case that nothing gets drawn beyond the edge of the map, so it doesn't make sense to really keep following the character as they get past that point. So that was it for the movement update. So the next update, Mario 6, is going to be a little bit meatier. We're going to actually talk about states. We're going to talk about different animations. We're going to have an animation class, and things are going to get a little bit more visually interesting with our avatar itself. So see you soon for Mario 6.